A very good morning to Sir Hazim. Today our group will present on vector and scalar in mechanical engineering. My name is Ras Xavier Michael and I'd like to introduce my group members, Tommy Robert, Frederick Tambi and Hazik Amri. The first part will be presented by Tommy Robert.
Introduction of vector and scalars. A quantity that has magnitude but no direction is described as scalar. A quantity that has magnitude and acts in a particular direction is described as vector. This is a difference between scalars and vector. Scalar quantity only have magnitude. For example, 11 meter and 15 meter second -1 are both scalar quantities. Scalar quantities include distance, speed, time, power, and energy. For vectors quantity have both magnitude and direction. For example, 11 meter east and 15 meter second -1 and 30 degree to the horizontal are both vectors quantities. Vector quantities include displacement, velocity, acceleration, force, weight, and momentum.
Hi, my name is Frederick Tambi. Today I present about application of vector and scalar. Vector used in engineering mechanics to represent quantity that have both magnitude and direction. Many engineering quantity such as force, displacement, velocity, and acceleration will need to be represented as vector for analysis. When dealing with vector in equation engineering, commonly denote something as a vector by putting an error over the variable without any error over top of them represent a scalar quantity or simply the magnitude of that vector quantity. To represent a vector quantity, we will generally have two options. These two options are magnitude and direction form, where the magnitude is given as a single quantity and the direction is given via an angle or combination of angle. Two component form, where the magnitude and direction are given to component magnitude in each coordinate direction. The drawing above show a force as vector. On the left, the vector is represented as magnitude and direction. On the right, the same force is represented in terms of its x and y component. Thank you.
Mathematical solution of vector and scalar. Number 1. A boat travels west at a speed of 28 meters per second across a river that is flowing south at 11 meters per second. What is the velocity of the boat? The solution is find the magnitude. C equal 28 square plus 11 square equal square root 784 plus 121 equals square root 905, and the answer is 30.08. Next, find the angle calculation. Tan theta 11 per 28 tan theta equal 0.393. Move tan to the side so it become tan negative 1. Tan negative 1 multiply with 0.393, and the answer is 31.45 degree. Therefore, the velocity of the boat is 30.08 meter per second. Question number 2 is, a plane flies south at 750 mph with a crosswind toward the east at 149 mph. What is the velocity of the plane? The solution is, first, find the magnitude. C equals square root 750 square plus 149 square, which equal to square root 562,500 plus 22,201 equal to square root 784,501, and the answer is 885.72. Second, we find the angle. Tan theta 700 per 149. Tan theta equal 5.034. We move tan to the right, and then it will become tan negative 1 multiply 5.034 equal to 78.76 beta. Therefore, the velocity of the plane is 885.72 meter per second. Okay, that's all from me.
So in conclusion, vectors have a crucial role in our daily lives as well as in engineering. In mechanical engineering, vectors are used to express quantities that have both magnitude and direction. For analysis, many engineering variables including force, displacement, velocity, and acceleration must be represented as vectors.